Very good morning, students. For this lecturing video session, I am going to solve a problem from projections of solids. Let me just read out the question and try to extract as much as information which is given in this question. A tetrahedron of 40 mm side rests with one of its edges on HP and perpendicular to VP. The base is inclined at 30 degree to HP. Draw its projections. So, the given data, the object here is a tetrahedron. The object here is a tetrahedron of side 40 mm, of side 40 mm. 40 mm side rests with one of its edges on HP. Where it is resting? It is resting on HP with one of its edges. That means resting on HP with one of its edges. With one of its edges. That means edge. And edge is resting, right? And perpendicular to VP. The base is inclined at 30 degree to HP. Here the axis is not inclined. Here the base is inclined. Base is inclined to HP at 30 degree. Right. So here the object is a tetrahedron. You all know tetrahedron has 4 equal regular equilateral triangles. Right, look at here. One first triangle, second triangle, third triangle, and the fourth triangle. Isn't it? So, it has equilateral triangles, 4 equal equilateral triangles. These are edges or sides. These are corners. When you just keep it over here, this is as an apex or vertex, right? These are the triangular faces. These are triangular faces. So what the question says, it is resting with one of the edge. Therefore, edge should kept on the right hand side, whether this side or this side. This side should kept on the right hand side, right? And the base is inclined. The base, assume it is resting in this manner. Therefore, this as a base. So, this base is lifted 30 degree inclination with HP. This is the final posture or position. So, in order to draw the true shape, this should be kept vertical. That means one axis, that the axis should be kept vertical or perpendicular to any one of the plane. Since it is inclined, it should be kept in this manner. So, in place of the base is inclined, suppose it is mentioned one of its triangular face is inclined. If the question says the triangular face is inclined at 30 degree, in that scenario, how that should be kept? So, this is the triangular face, right? Edge has been kept here. If you tilt in this manner, now it is making some inclination with HP. That means the triangular face is making some inclination with HP. Whereas here, the base is inclined. So, it is resting with one of the edge and base is in this manner. So, assume this as base, where it is resting on the HP. It is resting here. So, the base is inclined. So, here it is making 30 degree, not here. So, it is the base. So, base is making some 30, this is the final position. So, when it is the axis is perpendicular to HP, this is how the object would be placed. When I look at from the top, I could see the triangular shape, isn't it? So, the shape would be visible, that the true shape would be visible on HP. So, I am going to start the diagram on HP. So, above XY is VP, below XY is HP. So, this as far as projection of solid is concerned, 2 stages. The first stage is for the symbol position or symbol resting. Symbol position or symbol resting. And the stage 2 belongs to axis inclination. Axis inclination or special conditions. Here axis is inclined, axis is not inclined. Therefore, it is a special condition problem. So don't jump into the conclusion some inclination is given, that could be axis, which is wrong because base is inclined. Remember it. So here, as I said, the edge should be kept on the right hand side. So starts with a vertical line of 40 mm. So if it is 40, all the three sides are 40. Therefore, take 40 mm in your compass. Keeping at the top, cut an arc. Similarly, keeping at the bottom, cut an arc. This intersection point. Now, just connect everything. So by doing so, you get a equilateral triangle. So when I look at from the top, not only I could see the triangle, assume this is a base, not only the triangle, I could see the slant length also, isn't it? Right. So how that can be drawn? So the corner, this is a corner, right? Opposite of the side, mark the midpoint. Similarly, this is a corner, mark the midpoint of the opposite edge. So now draw a line connecting those. By doing so, you will get an intersection point which is nothing but the apex, right? So now connect all the corners. Now connect all the corners. Connect all the corners. By doing so, you will get the top view of this particular tetrahedron. So the intersection point named as O. Let me just give naming A, B, C. Right? So in order to draw the front view, I need to project all the corners vertically upwards. Vertically upwards. Right. So now this is the axis. Right. This is the axis. So axis should be represented long line dot, long line dot, long line dot, long line. Right. Here axis side is not there because all the four sides are of equal length or side, right? If it is 40, here is also 40, here is also 40, this is also 40, this is also 40. When the object is kept in this manner, when you look at from the front, this could be, is not a true length. When the line which is parallel to xy, look at here, this line is not parallel, whereas this length is parallel to xy, therefore you could see the true length over there. So true length is nothing but 40 mm, isn't it? So all the sides are 40. This is 40, this is 40, this is 40, this is everything is 40. So this line is parallel to xy, therefore you could see the true length. Measure 40 mm in your compass. Keep it at over here. Now cut an arc. Now cut an arc. This could be 40. This could be 40. Now draw the base. Close the boundary. Right. So anything else is visible when you just look at from the front. If the object is in this manner, right? Only you could see these are the two slant edges, right? These are the two, 1, 2, and this one which has already been covered. So when you look at from here, what are the points are visible? A, B, and O are visible. This could be O dash. A is visible, this could be A dash. And B is visible, therefore B dash. What about C? C is right behind B, therefore C is invisible, which can be marked in a bracket. So this is simple position when the tetrahedron is resting on HP with one of its edges. So let's move to the second stage, which pertains to axis inclination or special condition. As such, here there is no axis inclination for the given problem. What it says, base is inclined 30 degree. As such, it doesn't have any base, but the one which is resting on HP is termed as base. So now it is in this manner. If I tilt the base, now it is making 30 degree with HP. This is what I am going to draw. Right. Let me just choose a point. That is B 1 dash C 1 dash is resting. Right. This is how B, C are resting. This is how I am going to lift it. So A will be lifted from XY line. Right. So now measure this distance. This distance, or this should be 30 degree, right? So measure. So draw 30 degree line. This is 30 degree. Which is 30 degree incline? This base AB. Measure it from AB and cut an arc here. This could be A1 dash. This base is inclined now. This is making 30 degree. Remember it. Don't get confused. So where it is resting, that base is being lifted. Now measure the distance between AO in our compass. Keeping at A, cut an arc. Measure B to O in our compass. Keeping at B, cut an arc. Now connect it. Connect it. What about this point? This could be O1 dash. So this particular object has been tilted. Now the axis, measure it from B to O. B to here. This could be axis. So axis. Right. So in order to draw the final view, either it could be top view or the front view, what you have to do? You will have to simply project it from the projectors from the front view, and similarly from the top view, horizontal projectors. Draw horizontal projectors. Right. Now look at the intersection points. I will have to mark the intersection points. A is here. A are meeting here. Therefore, this could be A1. B is here. Let me see the meeting point. B and B are here. This could be B1. C is here. C and C are meeting here. This could be C1. What about apex? So O and O are meeting here. This could be O1. So what is the rule to draw the final view? First is boundary should be closed, because boundary is always visible when the object is tilted at anywhere. Either in this manner or in this manner or in this manner. Boundary should be always visible if the object is tilted, right? So let me just connect all the boundary first by using scale. So boundary is being closed now. Now I need to see the triangle face, that is the slant ends, that is AO, BO, OC or base. So base ABC, right? Which is already been connected. So let me just take that as a base. A to B, B to C and C to A. This is how it is been interlinked. And what about the slant edges? That is OA, OB and OC. Base is already been connected. Look at here. A to B, B to C, everything is connected, right? A to B is connected, and look at here. Now what about here? This is A, this is B and this is C. When this is been lifted in this manner, I could see A to B is connected and A to C is connected, whereas B to C is not visible when the base is being lifted 30 degree. So BC is invisible to me. So that needs to be mentioned as dotted line. Right. So base is being covered, A to B, B to C, C to A. A to B, B to C, C to A. That's how the edges are connected, right? So this is over. Let's move to the slant edges. OA. OA. When the object is being tilted in this manner, when I look at from the top, I could see OA. Therefore, OA is visible. OA is visible. Now, what about BO? Which is visible, which is already been connected in the boundary. What about OC? That is also visible, which is already been covered. So it's very simple if you do the checklist here. If you write the checklist, and you won't go wrong. You won't miss any of the corners or edges or vertical edges or the side or whatever. So by doing this, I have completed all the 4 views. That is the 2 front views and 2 top views. Next what? Dimensioning needs to be marked. Right? Dimensioning, let me just mark it here. This is 40 mm. Either side, either I can just mark it here or here or here. This is convenient for me, therefore I marked 40 here. And make sure if a line is parallel, this length, that would be 40. So remember this is parallel, so I am just marking here, this is 40. And 30 is already been marked. What is next? The nodes. All dimensions are in mm on scale 1:1. Right. So the right behind, there is a right bottom of the drawing, you should mention all dimensions are in mm. All dimensions are in mm. If you have drawn the diagram in centimeter, then you should mention that as centimeter. Here, as such, I have not even changed anything, that is mm. Same thing I have mentioned here, therefore all dimensions are mm. Then what about scale? As it is I have drawn, that is 40, same thing I used 40, therefore I haven't changed any scale, therefore that could be true scale, that is scale 1:1. Hope you have all understood the projection of solids for the solid tetrahedron. Thank you.